On graph hyperplot points A, B, C, D, you can see everyone kind of set this up. A was at -2, I'm sorry, -1, 2. B was at 0, 5. C was at 2, 5. And D was at over 6, up 2. What type of shape is ABCD? Justify your answer. One of the things I know is that two of these lines have exactly the same slope. They have slope equal to 0. So because of that, I know that BC and and AD rather are parallel. So if I look at the list of definitions of shapes that I have, this is a quadrilateral in which exactly two pairs of opposite sides are parallel. So this is a trapezoid. And I put this down here, AB and AB, I'm sorry, BC and AD are parallel because they're both horizontal. They do have the same y values there, so they have a slope that equals 0. So this is a trapezoid. So we're starting out with the trapezoid. Let me move this out of the way. The next question says, take this trapezoid, and in part B I'm supposed to rotate it 90 degrees counterclockwise about the origin. Name the coordinates of the image. So it's been a while since we've talked about or looked at this, so let me explain my thinking to you. I consider the origin and this point right here, so this point. And if I look at that, that is -1 up 2, right? Now, if I wanted to get something that was, if I wanted to make a right angle with that, that's the exact same segment, I'm going to take the opposite reciprocal. Right now I'm going, for example, I'm going up 2 and back 1. So what I'm going to do is I'm going to go back 2 and down 1. This point right here is the point that that point is the point that it's the opposite slope triangle right there. So this is a right angle with the original one. So this actually gives me some insight into the rules for a transformation that would be a 90-degree counterclockwise rotation. In fact, let me write the specific points down that I have. So I have, for example, that x was -1, y was 2, but after applying this transformation, you can see that x became -2, and y, let's see, and y became a -1. So if you look at it, you can see what's happening here. X and y's are switching spots, right? Where x is just going to go into the place of y, and the y is going to come up to where x is, but it's going to switch signs. So we're looking at something like this, right? We're looking at xy is going to get mapped onto the opposite of the current y value will become x. So the opposite of y where you're at is going to become x, and x and y rather will become whatever x was. So this is going to go here. So it's like they're switching places, and the when y moves, we're going to switch the sign of that too. Now, I'm going to apply this particular rule that I just wrote down for all of these points. And the first point, of course, is this one. This is now a prime, and it's at the point -2, comma, -1. So let's try this for point B. So I'm seeing B is at 0, 5. So what I'm going to do is 5 is going to become the new, let's see, right now y is 5, so y is going to become, so x is going to become the opposite of y. So you can see right here, I'm looking at this point, this is at 0, comma, 5. So what's going to happen is this y that I have is going to become my new x. So x is going to be -5, and then this is going to just be 0. So when I do this rotation, it's going to be -5, 0. So this is 1, 2, 3, 4, 5. This is now my B point, and it's at -5, comma, 0. So I can see I've got the A and the B down. This is B prime. I'm sorry, not A prime, B prime. Now I'm going to do the same thing for C. C is at 2, 5, and I think I want to come down here and think about this again. So C currently is at 2, 5. So what I'm claiming I'm going to do is I'm going to flip these numbers, right? So this is going to become a 5, and this is going to become a 2, but I'm going to take the opposite sign of x. Whatever y was, it's going to become the opposite of that when it becomes the x. So now I'm looking at negative 5, 2. So let me write this down here. So negative 5, and up 2. I believe that this is the point C prime. And the last point that I need is I need to figure out D. And you can see D is at 6, 2. So let's play the same game with D. D was at 6, 2. So I'm just going to flip them. I'm going to write it as 2, 6. And this is going to become the opposite. So negative 2, positive 6 should be where D primed is. So let's look at negative 2 and then up 1, 2, 3, 4, 5, and 6 right here. This is going to become D prime. And it's at negative 2 and positive 6. So let's connect those points. Let me grab the line segment tool here, and I'll connect them with this orange. So I'm going to connect first A. Oops, I wanted to grab the straight line tool. I'm going to connect A to B prime, and then I'm going to go B prime to C prime, and then C prime to D prime, and then I'm going to go from D prime back down to A prime. And you can see the effect is quite amazing. Of course, it probably would help visually if I got rid of this little right triangle that helped me think about this rule. But now that I've got the rule kind of all mapped, oh, I did not want to do that. Now that I've got this rule all mapped out in my mind, I probably should like try and, not erase everything. I probably should try to remember this, because that's pretty helpful, right? I'm flipping X and Y. But X is going to become the opposite of Y was. But that definitely produced a 90-degree rotation of that trapezoid. Let's take a look at the last part here. That was a tough question. Oh, I guess that's not the last. There's two more parts here. So let's see. This next one says, on your graph, reflect A, B, C, D across the y-axis to find A double prime, B double prime, C double prime, D prime. Name the coordinates of both A and C. So let me let's move down here and look at this diagram again. Okay, so this is a nice clean diagram. I'm back to the original 4 points, and what we're going to do is we're going to reflect this across the y-axis, which is pretty straightforward. In fact, one of the points won't move at all. In fact, that's this point. It's going to stay exactly where it's at when I reflect it across the y-axis because it's on the y-axis. Let's see, A is going to go to this location. So when I reflect it across y, it'll move over. D is going to be way over at negative 6, positive 2. So 1, 2, 3, 4, 5, 6. This is negative 6, 2. And C is going to be at negative 2, 5. So when I look at those, let me grab the green color pen and the line segment tool. So if I was to plot these, this is the trapezoid now. It goes from here to here, from here to here, from here to here. Oops, just trying to drag straight line tool, sorry. From here to here, and then one last segment from here to here. So you can see that it's definitely symmetrical there about the y-axis, and the thing just got flipped over. The problem did ask me to identify the coordinates of point A and C in the new diagram. So when I look at this, A, the new A is going to be right here at, this will be at the point, this is A prime, double prime. It will be at the point 1, 2. And the other point was C, and C is going to be this point right here. This will be C double prime. And that will be at the point negative, let's see, that should be, C should be at negative 5. No, it will, I'm sorry, it will not be at negative 5. It'll be at negative 2, negative 2, 5. So those are where the point C moves to this point, and the point A will move to this point after I reflect across the y-axis.